Okay, these are the examples for Algebra 2A Credit 1, Lesson 1.2. In this first graph, we're actually going to answer 5 questions from this graph. Now, first thing for number 1, so this will be our example for number 1 here. I'll just put 1 there. And we want to know where the graph is increasing. All right, so one way to think of this is increasing is imagine you're on a roller coaster. And this roller coaster is going to move from left to right, not right to left, so only left to right. And so imagine a roller coaster moving from left to right, and we want to know where that graph would be increasing. Well, imagine here climbing up the hill, and so it's increasing here at this first part of the graph, but then it's no longer increasing, it's going down. But then here, when it reaches the bottom, it does start increasing again. So there's 2 intervals on which this graph is increasing, and we're going to write these as inequalities. So notice that the graph here is scaled by twos, or no, excuse me, by ones. Ones on the x-axis actually, and by twos on the y-axis. But right now, we're just looking at the interval, so we're concerned with the x-axis. So the increasing interval, and let's get a ruler here to help us see this. So from -3 to -2, so this would be -3 here because it's between -4 and -2. So from -3 all the way to -12, the way one space, one unit. But from -3 to -2, it is increasing. And so from -3 to -2, the graph, we would say that the graph is increasing. By the way, notice we're not including -3 and -2. Why is that? Well, at -3 is where we're starting. We haven't done anything yet. So technically, right at -3, it is not increasing. Also, at -2 here at the top of the hill, at that point, the graph is no longer increasing. So that's why we're not including the end numbers of the interval. So just we are going from -3 to -2, but not including those numbers. Now, also it's increasing again. So after it increases and then goes down, it increases again, starting here at +1. So this is 2. This would be +1. So from +1 on out into infinity, and then writing that as an interval, it would look like, as a inequality, it would look like this. So from +1 on to infinity. So x is everything more than 1 all the way up to forever, to infinity. All right, next is, for number 2, we're going to talk about where the graph is decreasing. And we kind of avoided using the word decreasing on where we're doing example for number 1. But where we say it was the roller coaster is going down here, so up, then down, and then up again. So where it's going down, we would say it's decreasing. So what is the range of values for which the graph is decreasing? Well, it starts decreasing right where the increasing left off here at -2. And it's decreasing all the way down here, all the way up to +1. So this would be 1 here because that's 2, that's 0. So from -2 to +1, our graph is decreasing. And that's the only interval where the graph is decreasing because that's the only part of the graph where it's going down as we move from left to right. All right, so now for number 3, so we've talked about where the graph is increasing, where it's decreasing, and now let's talk about what we call a local maximum. Now you might look at the graph and say, well, maximum, the graph goes up forever. Now, and that's true. If we had just said maximum, the maximum value of this graph is infinity because it goes up forever. But when we're talking about the local maximum, we're talking about the top of the hill here. And so we want to state the coordinates for that point, the top of the hill here. So that would be at -2. Now careful, the x-axis is scaled by 1s, but the y-axis is scaled by 2s. So this would be 2, 4, 6, and 8. So this would be -2 and 6 because we're up to 6 there. So our local maximum is at -2 and 6. So in a similar sense, now the local minimum, and again, yes, the graph does go, well, actually it doesn't go down forever, it stops here. So, but if it had gone down forever, that would be a minimum, but as it is, the minimum is the bottom of the hill here. And so our local minimum would be this point right here, which would be at 1 being between 0 and 2, obviously. 1 and -4. It's hard to see that there, but that's -4. So 1 and -4 would be our local minimum. All right, and finally, the last thing they're going to ask you are the zeros. The zeros are the values of x that make the function equal to 0. From a graph, we can identify those from the x-axis where the graph touches or crosses the x-axis. So we have a 0 here at this x-intercept, also at this x-intercept, and at this x-intercept. So those are the zeros. Here at -3, here at -1, and there at +2. So at -3, -1, and +2. So those would be our zeros. All right, so that is that for problems 1 through 5. Now, let's erase that. We're going to take a look at an example for problems 6 through 10. It's very similar to what we did on 1 through 5, but just looking at another example so we're best prepared to do all the work here. And again, if there's a lot of information, if you want to, of course, always pause, rewind the video to help you see things more clearly. All right, so this is our example for problems 6 through 10. And again, it'll be pretty similar, although the graph is going to look a little bit different than we saw in the last example. So let's go ahead and let's see how we're scaling this here. It looks like we're going by ones, and they're marking everything. So -1, -2, -3, -4, 1, 2, 3, 4. And let's see how far we have to go up here. 1, 2, 3, 4, 5. Let's maybe go up to there. And -1, -2, -3, -4, I think is far enough. Okay, good. All right, so we're going to cross here, here, and here. And we're going to max out there and minimum there. Okay, so let's go ahead and sketch that in. And let's go ahead and answer pretty much the same questions that we talked about in the last example. All right, so first of all, and this is for problem number 6, where is the graph increasing? Well, this time there is only one interval where the graph is increasing. And again, remember, we're looking at this from left to right. So on our roller coaster here, we're going down, 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 or decreasing. And now here, at this point, we start increasing. We start going up all the way to here before we start decreasing again. So the only interval on which the graph is increasing would be here between -3 and 0. And again, remember, we are not putting equal signs because right at -3, where it bottoms out, so there's no increase there, and at 0, where the graph tops out here, it's no longer increasing. So that's why we don't have the equal signs at -3 and 0. All right, now next, for example, for number 7, where the graph is decreasing. So this time the graph is decreasing on 2 different intervals, and we'll kind of try and highlight those in green. So as we start, always working left to right, we're going down or decreasing here, and then also decreasing over here as well. So the first interval over on the left, it's going up, yes, but also out to -infinity. So it's decreasing from -infinity all the way up to here where the graph bottoms out here at -3. So from -infinity to, whoops, forgot the inequality there, to -3, the graph is decreasing. And then the other interval, so after we decrease, we increase, and then we go down or start decreasing again. That would start here at 0 and continue out we're going down, but also out to infinity. So from 0 to positive infinity would be the interval, the other interval on which the graph is decreasing. All right, so these are examples for number 6, number 7. So an example for number 8. Number 8, that's our local maximum. And let's go ahead and write that in there. So that, remember, is the top of the hill. So our local maximum would be right here at the top of the hill. Remember, we always start plotting a point from the origin. So there's no left or right. We just have to go up 4. So no left or right. So x is 0 and y is 4. So our local maximum is at 0 and 4. Our example for number 9, our local minimum is the bottom of the hill, or if you want to think of it as the valley. Over here, which would be this point right here, which would be 3 to the left and 2 down. So that's -3 and -2. That would be our local minimum. Finally, our example for number 10, just double checking, making sure we're not skipping anything. Okay, excellent. So we have our zeros. So they want us to state the zeros or the x-intercepts of the function. And so that would be, again, the points where the graph crosses the x-axis, which would be here, here, and here. So that would be, our zeros would be at -4, -2, and +2. So we would say x equals -4, x equals -2, and x equals +2. And that is it. All right, so those are the examples. Let's make that look a little bit nicer, somewhat at least anyways. All right, so that's it, the examples for lesson 1.2. So again, do your best, rewind the video as needed, and you're going to do great. So, all right, take care, God bless, and we'll see you in the next video.